Alright, this is an introduction to the conservation of energy lab, and something that we know about energy, that it is always conserved in the absence of work. So suppose I had some energy that I'm starting out with, then what we can do is we can say if I were to take away any work, that has to be equal to the energy at some later point. Now I am taking it away, I'm kind of assuming that we're having friction, but if we were to do some work, then we would technically increase our energy. For this particular lab, we're not going to have any work. When it comes to energy, we have three flavors. We have spring energy, so 1/2 kx squared. We have gravitational potential energy, so mass times gravity times height. And we have kinetic energy, 1/2 mass velocity squared. In the absence of work, then the energy at the end of the day has to sum up to be the same exact number. So we could say if we're touching a spring, then we have 1/2 kx squared. If we are up on a ramp, then we're going to have mass times gravity times height. And if we are moving, we have 1/2 mass velocity squared. I'll go ahead and put kind of some 2 subscripts on here and some 1 subscripts on here. Now for this particular lab, we're not touching any springs or anything like that, so we can get rid of these guys right here. And we just have height energy and speed energy. So here's what we're going to do, is we're going to go ahead and pop open the simulation. So pop this guy open. I've already kind of done so and arranged it nicely on my screen. So here we can go ahead and take a look at energy. Here we have kinetic, potential, and thermal. If we had some friction, we'll get to thermal in a couple of chapters. I have you put the grid on here in this, and all I have you do is I have you place the skater at some particular point. Actually, it's 4 meters, so I'm not going to do that. And we're just going to go ahead and let these guys slosh back and forth. Now, what you can kind of see as this guy does his thing is you can kind of see the energy sloshing back and forth between potential and kinetic, but at the end of the day, it always sums up to the same amount of total energy. So energy is indeed a conserved quantity. So now we can pop back to the lab really quickly, and all I have you do is calculate what the energy must be at the top, calculate what the kinetic energy must be at the bottom, and then calculate how fast the skater would be moving. Then we're going to go ahead and change the ramp, and we're going to leave everything kind of as it was. And I have you put the skater 2 meters on the left side of this little W thing. So if I were to come back to this guy, then you can pick this guy right there. And I have you put the skater just right here and make a prediction whether he makes it over it or not. Get rid of that. Then all I have you do is I have you move him up higher, calculate what the kinetic energy must be at the bottom of the ramp, calculate the gravitational potential energy at the 2 meter hump must be, and then what kinetic energy must he have at the 2 meter hump. All you're using is conservation of energy for this guy. Then I'm pretty straightforward. I just say, hey, what happens if we have some friction? Remember that friction is going to take away some of that energy. Bear in mind that it doesn't just, spread it out into the ether. It actually goes into another flavor of energy, and you'll see where it goes.